Okay, so let's now have the third case for subdivision of land, which is to cut off a required area by a line through a given point. So I suggest you first read Module 12 about subdivision of land, which discuss the idea of how to deal with cutting off a required area by a line through a given point as the third case for subdivision of land. Now, by the end of the lecture at that module, there is an example left, example that fits that certain case, to which we are going to explain its solution. So again, the example says that a tract of land with adjusted latitudes and departures given below is to be subdivided into two lots of equal area, or rather equal areas. Okay, final length and direction of the dividing line, which is to pass through corner B. So what will happen there is that, okay, since the given data is or are the latitudes and departures of each course, it would be convenient if we get first the length and bearing of each of the courses. So now you already know how to get the length and the bearing given latitude and departure. So let's say we already have them right here. Let's say we already have solved them, and then this would help us, the length and bearing would help us sketch the traverse. So we have traverse A, B, C, D, E, F. Okay, so our dividing line will again, so say we already sketched using the lengths and bearings of each of the course of the given traverse. So this one you have A, B, C, D, E, F traverse. So our dividing line would pass point B, which is this one. Okay, and this imaginary line here will represent as the dividing line that would divide the whole area into two equal parts. So if this is our dividing line, it passes through point B. Okay, and then let's say the other point, we name it as point P. Okay, given that the line BP will be the dividing line, therefore it should be that the tract A, B, P, E, F, okay, the area of that tract which is below the dividing line should be equal to the area of the other tract that is above the dividing line, which is tract B, C, D, P. Okay, so therefore the area ABPEF, the area below the dividing line BP, plus the area above the dividing line, which is area BCDP, should be equal to the whole area ABCDEF, where we know that if the dividing line is to divide the whole tract into two equal areas, then area below, which is area ABPEF, should be equal to area above the dividing line, which is BCDP. So therefore we have that area, or these areas being equal, are both equal to the whole area divided by 2. So in that case, it would help us if we determine first the area of the whole tract. So you have area of whole traverse, which is area ABCDEF. So you already know how to solve it given their latitudes and departures. Let's say we use the MD. So the summation of the double areas is equal to 3,430,192.54 square meters. We need to divide that by 2, so therefore the area of the whole traverse area ABCDEF is 1,715,096.27 square meters. In that case, Okay, in that case, area below and above, both the area below and the area above the dividing line is equal to half of the whole area, which is equal to 857,548.135 square meters. Okay, so now if we are going to base on our sketch, a rough sketch, okay, this sketch of mine is not really scaled, so it would be hard for us to tell. We can't directly say that it actually lies at line DE. It could be that line or point P would lie at this line, okay, or it could also lie at the line CD, but I think looking at the sketch, it would be impossible that it lies at line CD, but anyway, we are going to confirm it. So let's say this would be my trial line. This trial line is line BD. Now again, for this third case, it would always be convenient to use a trial line. So for this trial line, line BD, what I am going to do is to get this area BCD, okay, and if this area is less than half of the whole tract, then therefore it is impossible for line BP, the dividing line, to lie at to intersect line CD. Okay, but if this area, okay, is less than the half of the whole area, then it could either lie point P could either lie at line DE or line FE. We will also confirm. So what will happen is we solve for area BCD. So we already have the latitude of BC and CD. We are yet to determine the latitude and departure of line DB. For this area, this would be the closing line, line DB. So for that, you already know how to, and if we get the area using DMD or DPD, area BCD is 330,000. And since it's less than area BCD, or rather area BCD is less than half of the whole area of the tract, therefore the dividing line does not intersect at line CD, so it would be impossible for the dividing line to intersect this line, or point P does not lie at line CD. Okay, but it may either point P may either lie, okay, either at line EF or at line DE. So it could either intersect right here or right here. Okay, we will confirm. So how to confirm that? We will solve for area, this area. We will solve for this area, A, B, E, F. Okay, so we have A, B, E, F. This one. Okay, so area A, B, E, F. Okay, if this area is less than supposedly half of the area of the whole tract, then point P lies at line DE. But if otherwise, then it lies at this line. So we will confirm. So we know how to get area of ABEF. So we'll have courses AB, BE, EF, and FA. Don't have yet the latitude and departure for BE, so we could solve for that. Then we could use the MD to get the area ABEF, which is 656,339.831 square meters. Since this area, okay, area ABEF is less than half of the area of the whole tract, then therefore it is correct that point P actually lies at line DE. So the position of our dividing line BP, okay, intersects this line DE, or point P lies at line DE. Okay, next, since based on our previous solution, line DB, okay, the trial line, this trial line, okay, its latitude and departure are both negative. So that means its direction should be southwest from point D. And since from the drawing we could see that it is at the direction northwest, then it would be better if we redraw the sketch. So we now here we now have this new drawing of the traverse. Now, if this is our dividing line, okay, we could use a trial line. Now remember that a trial line, okay, in this case, if the dividing line passes through point B, then your trial line should also pass at point B, so that we could conveniently have a triangle out of the whole traverse. So if we choose line BD or DB as our trial line, then it would help us solve for what we are looking for, the length of the dividing line and its bearing. Okay, so this is what's going to happen. Line BD, we already have its latitude and departure, therefore we could determine its length and bearing. So if this is its length and this is its bearing from D, or from B, this will be its bearing, and we have here a given bearing of line DE, then therefore we could get the interior angle at this station D. Okay, so this will be the interior angle for this triangle BDP rather. Okay, so this is point P. Okay, then we could have this length, and we know that this area right here, okay, is half of the area of the whole tract. So basically, we already know the area of tract BCDP, which is above the dividing line. Okay, now we could actually also determine the area, or we already actually have determined the area BCD, this area. Therefore, knowing the area, this area minus this area is equal to the area of this triangle. Now, if we already have the area of this triangle and the length of one of the sides and this interior angle, then therefore, using one of the formula of the area of the triangle, we could get the length of this side. Okay, so we have the length and the bearing of line DB. Okay, that's 1419.678 right here, and the bearing is 79 degrees 26 minutes right here, 53.16 seconds. And we know that the bearing of line DE is 12 degrees 16 minutes 57.74 seconds. Therefore, the interior angle at D, you just add the two, 79.26 plus 12.16 is 19 degrees 43 minutes 50.9 seconds. So for this triangle BDP, the interior angle at station D is 91 degrees 43 minutes 50.9 seconds. And since we know the area, okay, the area of this whole tract above the dividing line is equal to 857,548.135, which is half of the area of the whole tract. Okay, that would be equal to the area of BCD, which we already solved, and is equal to 330,563.274. Okay, Okay, so you have the area of BCDP minus the area BCD is equal to the area BDP. Okay, so therefore area BDP is equal to 526,984.861. So we already have the area for this triangle. Now, I want you to remember, for a triangle, let's say we have here an oblique triangle having the corners A, B, C, and the angles, interior angles, okay, let's say beta, alpha, and phi. Okay, now we could use a formula, or there's a formula for the area of a triangle if two lengths of the triangle are given and its included angle is also given. Say for example, if line BC and length of line AB is given and also their included angle, which is angle beta, then therefore the area of that triangle is equal to 1/2 of the product of the two lengths, which is AB and BC, times sine of their included angle beta. Included angle means the angle between the two lengths. Okay, so the included angle of lines AB and BC is angle beta. Or if you also have length of AC and AB, and you also have the angle alpha, or the included angle of AB and AC, then therefore the area of this triangle is also equal to 1/2 of AB times AC times sine of the included angle of AB and AC, which is alpha. Or last one, for these lengths and their included angle, you have 1/2 line BC and line AC sine of their included angle, which is phi. So this is one of the formulas of the triangle, where it is equal to 1/2 of the two lengths of the triangle, product of the two lengths of the triangle, times the sine of their included angle. Okay. Therefore, if we have an area, area of the triangle BDP, and we have a given side, and we also have a given angle, then therefore we could actually use this formula of the area of BDP. Okay, where 1/2 of line BD and line DP product times sine of their included angle, which is determined to be this value. Okay, so you have this formula, their angle at D. So 1/2 length of BD times length of DP. Okay, BD, DP, then their sine of their included angle. Okay, so therefore we could get line DP here. Okay, so line DP is equal to 742.739, and interior angle at D, okay, again, you just add the bearing of line DB and the bearing of line DE. So we have 91.43 right here. Okay, so substituting everything, we can get the length of line DP, which is 742.739. So I wrote here that the length of line DP is 742.739 meters. Next, okay, now out of the information in length BDP, so let's just rewrite BDP, redraw BDP. Okay, so again, this is station B, station D, and point P. Okay, since this is 1419.678 meters, this is 742.739 meters, and this is also the whole interior angle at D is 91 degrees 43 minutes 50.9 seconds. Therefore, we could get the length of line BP, which is the dividing line. So this is our dividing line. So we could use cosine law. For the cosine law, length of one line of the triangle, square of that is equal to the sum of the squares of the other lines minus 2 times the product of the two other lengths times cosine of the included angle of these two lengths. So length of BP, substituting everything, and therefore we have the length of the dividing line equal to 1621.987. In solving for the bearing, we could use sine law. Sine law, since we already have this length, okay, we could get this bearing, this interior angle at B, and we already have the bearing of BD, which is 79 degrees. Okay, that's 79 degrees 2653.16, 26 minutes 53.16 seconds. What we are looking for is the bearing of the dividing line BP, that is this one. Okay, so we could actually get the interior angle at B, this one. So by sine law, we have this length 742.739 over sine of its opposite angle, which is the interior angle at B, would be equal to the length of the line BP, which is 1621, this line, over sine of its opposite angle, which is 91 degrees 43 minutes. So we have the interior angle at B equal to 27 degrees 40 minutes. Therefore, bearing BP is equal to 180 minus this angle minus this angle, and that would be equal to 73 degrees 18 minutes southeast. So this will now be the final answers. Therefore, we already have the length and the direction of the dividing line BP.